Great, thank you. Well, thank you everybody for coming. First thing I want to say is if you want to grab the slides for this talk, there's a lot of resources here, so grab that bit.ly link down there. I also put it in the Q&A Slack channel, so you definitely want to grab that. So we're talking about next generation big data pipelines with Prefect and Dask. So the goal of this talk is to get you interested in Prefect or Dask or both. I can't really go super in depth with like a 20-minute talk, but the goal for me is to just get you interested, and then I'll provide some resources at the end. So if you stick around for just one slide, or you want to just steal the slides right now, there's one towards the end that has a getting started page with a bunch of different links to tutorials that you can check out. So I might be a little bit opinionated because I'm going to go through a bit of a history of data pipeline tools, introduce Dask and Prefect, and then talk about some other tools like Spark and Airflow. So I'm going to say things about a few of those different tools. Quick about me, my name's Aaron. I spent several years doing big data processing with Spark and then orchestration with Airflow. I'm really excited now to be living more in the Python native PyData world to do things with Dask and Prefect, which I'll introduce in just a couple minutes. Like I said, I'm going to be taking a couple shots at Spark and Airflow because I'm presenting maybe new and potentially like alternative tools to them. But I found a lot of value in them. A lot of people still find a lot of value in them. I'm presenting some newer options. Technically, I am a very, very minor contributor to the Prefect open source project, if you count one line of code, but I think that still counts. It was merged. And if you want to find me on the internet, there's some links down there. So quick about Saturn Cloud. If you want to find out more, check out our booth. We actually have a booth in the expo hall. You can check that out. I know I have a couple of colleagues on the Slack Q&A channel now if you want to talk to anybody about it. But basically, we're a cloud-based data platform for data scientists and their teams to get going and get up to speed really quickly. So we have cluster computing through Dask. We have GPU computing with Rapids and workflow orchestration with Prefect. We kind of put everything together in a nice, easy to use package where you don't really have to think a lot about DevOps, and data scientists can kind of get straight to work. So what we're talking about here is big data pipelines. And before I go fully into that, I want to start off with just what's in a plain data pipeline first. The main idea for a data pipeline is you want to process some data at some time. That's really it. And so you have a thing that you want to do with some data, basically, right? But when you actually go to build a data pipeline, you end up having to think about a lot of other things. And so you're writing code not to do the thing that you want to accomplish. You're writing code to handle failures. If servers go down, if data doesn't exist, and you're trying to write code to communicate between different steps and schedule things. And so that's really where a lot of the work in a data pipeline goes when you've already had like the thing that you want to do already defined. So when we talk about a big data pipeline, it's just a data pipeline with a lot of data and a lot of tasks. And so that might look like a bunch of small tasks that all have to be kind of orchestrated, and a lot of them are happening. So maybe each individual task is something small that you can do with like pandas or something, or you're doing something that has a few big tasks and you need some sort of distributed computing kind of big data processing engine where the task itself is one kind of unit and then the engine is actually handling some of the large scale processing for you. So how do you actually run either of these scenarios? And in real life, you're probably in a mix, right? There's probably some things where it's a big job and some things with a few different tasks all layered up. Well, the answer to really both of these is distributed computing. So for the first scenario, you would have a bunch of small tasks that you need to kind of distribute across multiple cores or multiple machines or something like that. On the other side is you're probably using some sort of cluster computing framework like Spark or Dask, and you kind of are writing your code there. And so in that case, you still kind of do need distributed computing and a cluster. So we're going to talk about those two things and really focus on two different sets of tools in this big data pipeline. And that's tools to actually write and orchestrate the pipeline. And that's where I'm talking about Prefect. And then a tool that will actually do big data and distributed computations, and that's Dask. So before we get into specifically Prefect and Dask, I do want to go through a quick history lesson because at the very least, I think this is interesting. It's a world that I kind of spent a lot of time in. And also, I think it does help give good context as to why I'm recommending now Dask and Prefect versus some maybe quote previous generation tools. So we'll start off with tools from the big data world. Basically, in the beginning, there was Hadoop, right? So way back when, the idea came from Google, but then it was open sourced at Yahoo. But there are a whole suite of tools, and the big breakthrough with Hadoop and the Hadoop ecosystem was that you could process large amounts of data on clusters of commodity hardware. So that made it so that you don't have to get like super crazy specialized hardware to do things. You can just, tie up a bunch of machines, create a cluster, and do some computing. So Hadoop created that paradigm and really created an ecosystem of projects that enabled companies to analyze large amounts of data. So in bold here, I have the processing tools, and then in the plain italics is the pipeline tools, just so you can kind of see which tools came out when. So when we're talking about processing, Spark was now a next generation on top of Hadoop. It was still kind of born out of the Hadoop ecosystem, built in similar paradigms and working with the same clusters, but it was like way faster to process data with Spark because it was starting to compute things in memory versus passing stuff between disks like Hadoop was. So Spark represented a really, really big, and it's still very, very popular, mature package right now. When it comes to pipeline tools, we saw a couple come out at the kind of early onset of the Hadoop ecosystem, like Uzi and Azkaban, and they were kind of pipeline tools that were built around the idea of configuration files for you to create your pipeline. So you would stitch together a few different Hadoop jobs with a config file, kind of clunky. Luigi and Airflow were a couple of tools that represented a newer paradigm and way of thinking in creating pipelines with code. So those two tools actually use Python code to define your pipeline, so it's much more flexible. You can build a lot more around it rather than specifying like XML or other things. And one thing to note with these tools, I put in parentheses the companies where these tools were created and open source from. So that shows that these kind of big data tools were created at super large consumer internet companies and were built to solve the problems at those companies, not necessarily the problems of everyone else. So especially when it comes to pipelining, as we'll see. Okay, hop over to a different world. Now we're talking about the PyData kind of data science world. And the one thing you'll notice here is that I don't have any pipeline tools listed on this side because there aren't really, like, through this history, not like one specific pipeline tool that came out. But the big thing here was that starting with the concept of a data frame from R, NumPy and Pandas brought array and data frame computing to Python, so it enabled a whole suite of scientific computing and then machine learning and a whole bunch of other data science focused stuff. And those packages, data scientists love, and those are tried and true mature packages in that ecosystem. But there's not quite a pipeline tool happening there. And before I go forward, I kind of need to back up a little bit, because if you back up way into the 70s, we are still using tools like Unix, cron, make to stitch together rudimentary data pipelines, right? Like if you have two Python scripts that need to run after another, what do? Python script 1, Python script 2, throw it in a bash script, put it on cron, schedule it, right? So that's kind of one of those things where it's like pretty easy to just put those two things together, but then you have to think now about all these failure scenarios and building other stuff. So the idea is, how can we really want an orchestration tool that is simple and easy to stitch things together, similar to like Unix, but also that can handle all of the failure scienarios that tools like Luigi and Airflow were kind of built for. So, and the thing too is that we're starting to see now this data engineering, big data, and data science, PyData worlds collide. Like we need scientific computing and machine learning on large amounts of data. And so these two kind of need to come together. We need better ways for data engineers to do advanced computing. We also need better ways for data scientists to write production pipelines. And that's why I'm talking about and presenting Dask and Prefect as this best of both worlds, this kind of next generation big data pipeline. And it's funny because I just listened to a podcast from the creator of Prefect, and he doesn't like to call Prefect the next generation on top of Airflow, because they do attempt to solve similar problems in similar ways. I think Prefect does it better. But the reason I'm calling this next gen is because of Dask and Prefect both together, doing your big data processing and your pipelining in these kind of Python native tools, which I'll talk about in just a second. So in reality, data engineers, data scientists, we're not all that different. And I have some kind of funny memes to talk about that, right? When we're working with Airflow, people, no matter who you are and what your experience is, you're probably kind of questioning, when is this task executing? Or with Spark, you get this weird heap space error and your Spark context dies and you're like, kind of, what's going on here, right? So I'm trying to present new tools that can be for both sides and kind of putting them together. So that's Dask and Prefect. Into Dask. So again, I'm not going to be able to give super in-depth on these tools. I'll have some resources later where you can kind of really read up on them, but I'm trying to just get you interested. So Dask is a distributed or parallel computing library based on dynamic task scheduling. And the idea is, from the very, very low level, you can parallelize arbitrary Python functions across a cluster. And it's 100% built in Python, built for the PyData ecosystem, and integrates really well. So on top of that low-level library, there are high-level libraries for data frames, arrays, and machine learning and other things that are, again, part of the PyData ecosystem. A Dask data frame is a bunch of pandas data frames kind of orchestrated by Dask. And a Dask array is a collection of NumPy arrays. So the APIs, first of all, mirror the APIs that data scientists are used to, and also you're working with familiar objects. And then Dask will run on your laptop and scale up to a cluster. And the link that I provide here for the scaling to clusters is there's several different deployment options when you're thinking about actually like building out and using a cluster. So here's what some Dask code would look like. I'm not going to run through this, but the main thing that I want you to take away from this is that this code looks a lot like pandas and scikit-learn. And that's the entire thing. I'm even using a scikit-learn class as part of this because the Dask ML package works really nicely with that. So that's really the idea, except now all of this code is executing in parallel across a cluster with big data. Okay, Prefect. So Prefect is a workflow orchestration tool in the same way that Airflow and Luigi are. But Prefect's idea and the whole idea around Prefect is that it basically doesn't want to be in the way. You use Prefect when you need to, but then don't think about it after the fact. And if you need to layer on more complex functionality, you can. And one thing, like I said about Airflow and some of those other tools, they were built at these large consumer internet companies to solve the problems of those companies. Prefect was built by actually talking to a wide variety of companies and different use cases, and then distilling down what was important in a workflow tool to kind of accomplish all of those cases. And honestly, super qualitatively, I just find it really fun to write Prefect code. I love the paradigm that it creates just for the entire concept of workflow orchestration. There's an entire vocabulary. Reading through the documentation is just like a really pleasant experience, and then writing code with Prefect is the same pleasant experience. And it'll use Dask under the hood for parallel task execution, which I'll talk about. So both Dask and Prefect are open source tools. Prefect has a commercial offering from a company of the same name, Prefect, and then there are a couple of companies kind of doing commercial offerings around Dask, Saturn Cloud, my employer being one of them. So here's some Prefect code. And the one thing I want you to notice from this is this Prefect code looks a lot like normal Python code. You can throw a decorator onto a function, and then inside of the flow, call functions as you would call normal functions in Python. And behind the scenes, Prefect is actually building up a graph or a DAG of all of these tasks, handling failures. You can add parameters for retries and like a bunch of different stuff. But from this kind of script itself, I might be missing a couple imports, will be like a standalone flow that you can run. And then you can run it straight from your code, or in production, you would have some kind of other system triggering a run to happen. And then when you were putting Prefect and Dask together, there's this Dask executor class that Prefect has. And basically, you can now pass any type of Dask cluster into that Dask executor, and then Prefect will execute all of the stuff, all of the tasks in your flow across that cluster. And so this is where, remember I said Dask has several different deployment options. If you have a Hadoop cluster or a Yarn cluster, you can kind of run Dask on that. You can use commercial offerings like Saturn Cloud. The example that I'm showing you is with a Saturn Cloud cluster. And then you kind of pass your arguments through there. Prefect all that Prefect knows is that this is a Dask cluster that I'm working with, and then they'll be able to parallelize those things. So any non-Dask work, like pandas, type stuff, will be kind of sent across the cluster. So it'll kind of be passed to a worker, run there, and if you have another task at the same time, it'll work. But then also, if you're doing this kind of a few big tasks type paradigm, where you're using the parallel Dask interfaces like data frames, arrays on big data, Prefect it'll also just kind of automatically work across the Dask cluster because there's a Dask client kind of available right there. So that's just, again, a quick intro to both of these tools. I'll give you resources very soon, but I do also want to kind of talk about these tools compared to like Spark and Airflow, right? Because like, why is there even a reason to consider different tools? Maybe if you're already using these, or if you're not using these, maybe I can convince you that you can kind of just skip this generation and go over to Dask and Prefect. Excuse me. So this is where I'm going to do it. I'm going to do the same thing for Airflow, but basically, if you encounter some of these problems with Spark, you might want to try Dask. And it's going to be, I'm not going to go super in depth for any of these points, But the idea is if you read a line and you kind of feel the pain and you resonate with it, you probably know what I'm talking about. And if you don't, then it's okay. You probably haven't just run through that workflow, but I'd say it's still probably worth trying out Dask. So first of all, if you've never used Spark and you're a Python developer, it's a much easier leap to go to cluster computing with Dask because it's Python native. So that's just a real quick point. Multi-dimensional arrays are really, there is no interface for it in Spark, and the way that their programming model is, it's probably not really possible to do so. Whereas with Dask, there is a kind of high-level Dask array interface that's a collection of NumPy arrays and then packages built on top of that. Okay, so this goes similar to my first point, but if you already have like a large code base in Python and PyData, Pandas, scikit-learn, NumPy, and you want to now, your data is just starting to get bigger and you kind of need to start thinking about cluster computing, again, Dask is a more natural fit. Spark has things where you can kind of bolt in kind of Python stuff, like you can do pandas UDFs and Python vectorized functions, but when you get outside of the kind of framework that Spark has, PySpark has to do things, it can be a little bit clunky. Whereas again, with Dask, you're dealing with an API on the DataFrame side that looks a lot like pandas. It's again, pandas under the hood, and then it connects with a whole lot more packages. This is a case study that I actually did at Saturn where we were looking at hyperparameter search, basically. I mean, the main point is that machine learning in Spark isn't really the best experience. There's a whole lot more algorithms available in scikit-learn just from the beginning, right? The grid search specifically in Spark is pretty slow because it actually doesn't parallelize training across your grid. It'll only parallelize an individual model. But if you're interested in seeing this article, you can kind of click the link there. This is one that I might be like triggering PTSD for some people. It always does for me, but you get these weird cryptic stack traces where you're like, I was just trying to like group by on a data frame, and then you get this thing that's like this big stack trace from Java, and you don't really know like what function actually failed and like what's being translated from Spark into Scala. So it can be kind of like a difficult time sometimes to figure out what's going on. And related, the Spark UI I think leaves a bit to be lacking, especially when it comes to like, I want to see what the heck my job is doing. On the right here is straight, I think, from the Spark docs where the code that you wrote didn't say parallelize, scan, whole stage, cogen, or any of that stuff. And so it's hard to like tie together from the code that you wrote into the UI and debug things. And not to mention that the resource utilization isn't really part of the UI out of the box. You have to kind of figure out how to get that from whatever cluster tool you're using. Whereas with Dask is executing Python functions just across your cluster. So you can see the progress of the specific functions happening in your job or whatever command you want it to run. And right from the dashboard, you can see specifically CPU, memory utilization, GPU utilization. Okay, I'm gonna do the same exercise except with Airflow and Prefect. And this list is a lot bigger. But again, it's one of those things, if you read a line and you know, then you kind of know, right? And I'm not gonna go through all of these specific things. And if you don't really want to take it from me and just read something else, you can click this link here that's from Prefect's docs, and they actually had a blog post when they first came out saying, why not Airflow? So all of the, basically a lot of the reasons why Prefect was created, and it is kind of, in my opinion, kind of a better solution than Airflow. Getting started is just one of those things. So Airflow was built to allow for a lot of complex things and a lot of fine-grained control of stuff. But the problem is you have to think about all of those fine-grained things right from the beginning. So this tutorial right here, your like first exposure to Airflow is like a lot of code, a lot of kind of new things, this template syntax, operators that might be kind of difficult to think through, and there's all these kind of arguments and options that you kind of need to think about passing. And so it's super powerful, but the problem is it can be kind of a steep learning curve, especially for someone on the data science side who isn't really a software engineer and hasn't really thought about like these kind of workflow tools. And then setting it up can be quite challenging as well. I know when I did a lot of work with Airflow, I never actually got it working locally, and I would just kind of hijack the dev server and like push to the Git repo until my DAG worked. So Prefect's getting started. This screenshot here is a full flow that I'm showing you here, and this is partially due to the Prefect code, but also again partially due to the way that Prefect thinks and introduces concepts to you. You get started with really, really simple examples, and you can get going quickly, and then you can layer on more complex functionality and just a little bit easier to get started with. These are more specific things, again, where if you've encountered a problem with execution dates, you know exactly what I'm talking about. Like all the confusion comes from the fact that the execution date is actually the start of the previous interval. So if it's a daily job, it's yesterday. But then if you trigger the thing manually, it actually gives you today's date. And so it's like, especially when you use the date inside of your DAG somewhere, it can get really, really confusing. Whereas with Prefect, a workflow is standalone. And if you want to execute on a schedule, you can attach a schedule. And there's a whole suite of classes there for you to kind of define fine-grained schedules. And then if you need the time information in your flow, you can add that as a parameter instead of kind of trying to overload two things on one concept. This is one that just Airflow doesn't really have out of the box, is parameterizing DAGs. And you kind of, a lot of the times you're going to need a parameter, so you end up putting like hacky workarounds through variables. I ended up doing a lot of that, and or putting like files on S3 somewhere just to be like a parameter. And so it's kind of clunky and not the best experience. Whereas with Prefect, there is a first-class parameter interface where you can pass it directly to flows. XComs, if I say that and it like warrants like a bad reaction, then that's pretty accurate. I do have some words about this, but basically XComs was something that was bolted onto Airflow. There wasn't initially a concept of passing data between tasks and steps. And so it's, again, kind of like a clunky thing, and you can actually like blow up your database by accident. Whereas with Prefect, data dependencies are handled just natively. It figures out what you're doing. The UI leaves a bit to be lacking also with Airflow. Like if you have a handful of DAGs, it's pretty good. But then if you have like dozens of DAGs and a bunch of tasks inside of each, it can be difficult to know like which one specific task failed. And then that's where the Prefect UI is really helpful, because there's a dashboard here that will give you a overview of all of the things that are running, all the things that failed, and then you can kind of dive in from there. Okay, so I know I breezed through this, but I hope I said at least like one or two things that made you interested in either Dask or Prefect. Besides the meme, these are open source tools, and then there are commercial options on top of them, but they are open source and free to try and free to use. And this is the slide that I promised you. If you want to just take this slide, grab the slides link, and then just use this, and then kind of ignore everything that I said, that's totally fine. These are kind of the way that I like to progress through learning a new open source tool, is to kind of get some context and overview to the tool. Why was it created? What problems does it solve from previous tools? And then do a quick hands-on tutorial that'll take you a few hours just to kind of work through, figure things out, and then you can take a deep dive into some docs. And then there are some articles here that we wrote at Saturn Cloud, some from Prefect, as well as some other kind of community members that I thought would be interesting for people to just learn these tools, because they're really fun. I think Prefect is even having a webinar tomorrow about migrating workloads. So I talked about this already, about how Prefect and Dask work together. Saturn Cloud offers kind of managed Dask clusters, and then we have a native integration with Prefect and Prefect's cloud offering, so you can kind of build stuff in Saturn and then kind of integrate it together. And these, like I said, these are complete open source tools, and there are awesome communities around these tools. So if you want to just talk about them, there's a Gitter for Dask. Prefect themselves has a Slack. Saturn Cloud, we also have a Slack that you can join where you can talk about all of these different tools. And if you want to contribute to them, they're open source, completely welcoming communities. Like I said, I did a Prefect contribution just a couple weeks ago, so you can definitely get going with those. And with that, I think I probably don't have time for questions, but if you want to put them on the Slack Q&A, you can join our Saturn Cloud Slack and kind of find me or find me on Twitter. I do want to give a big shout out to a couple of my colleagues, James and Stephanie. They helped a lot with the preparation of this talk and then helping review it with me, and they kind of listened to me rehearse it. So thank you again. And if you want to try out Saturn Cloud, you want to try Dask and Prefect, you can click the link here and start for free. So thank you very much.